So two expressions are equivalent, which means that they are equal. So remember, equivalent means equal. That should go into your vocabulary. If it isn't already added in, go under E and then write equivalent means that they are equal. And for example, I know that 4x is equal to 2x plus 2x. If I had 4 $1 bills, it's the same as having 2 $1 bills in one pocket and 2 $1 bills in another pocket. We know that they're equal in this case with expressions if I could substitute in numbers. So it'll be one thing is I could substitute in a value, or I can simplify. So to substitute in a value, I could say something like x equals 5. And I'm going to check 4 times 5. And I want to see, does that equal 2 times 5 plus 2 times 5? So I get 20 and 10 plus 10 and 20. So those two are equal to each other. That would be what I mean by substituting in a value. The next part is just a matching. I want to see our multiple choice, but I can pick more than one answer, so be careful. Some of them are a little bit tricky. And it says explain or show how you know. So I'm going to use distributive property here. I'm going to simplify this one to get 6 plus 12y. And then if I look, that's going to be this one here. I could also write this. It's the same to say 12y plus 6. That's that commutative property. I'm just switching things. But C is not that, because that 6 has a y in it. So the rest of them end up not working in this case. I'm going to look at the number 2. That's the one that sometimes people get a little bit more confused at. I need to actually do the distributive property on all these parts here. And I can look on some of these. 8 times 4 is going to give me 32k, and I'm looking for 16k. Not going to happen. 4 times 4 gives me 16k, so I'm going to check for the next one. 4 times 8 is 32, but I'm looking for 24, so that one doesn't work. 4 times 4 is 16k, so that part is good so far. 4 times 6 is 24, C works. Just because I have one doesn't mean there isn't another one. 8 times 2 is also 16k, so I check 8 times 3, that also equals 24, so that'd be another one that can work. I'm looking at 3. R plus R plus R plus R is also the same as 4R. It's not the same as 4 plus R, because if R represented something else and R equals 5, up on the top part, I'm going to have 20, and down here in part A, I'm only going to have 9. So kind of keeping those the same. R to the fourth would mean R times R times R times R, which is not the same as adding. But 4 with R in parentheses is also the same thing. We just don't always use those. You're going to try the other 3, and then you'll have the answers to check with them on those side. I wanted to look at number 7 and number 10. I think we'll look at those 2, and otherwise you're checking on these. Again, I'm combining like terms, so I'm going to combine my R's together to get 6R, and I can immediately cross that first one off because it's a 5R. 9 plus 3 is 12, so that works for this one. And then I'm just testing. 6 times R is R, 6 times 2 is 12, that also works. 3 times 2 is 6R, and 3 times 6 is 18. So that one does not work. Again, we're just we're simplifying things. We're putting things into different forms so that we can compare them using that distributive property in this case. Number 10, combining our like terms of 8 and 3 will give me 11k. And then this negative 8 and negative 14, treat those both as negative, is going to be negative 22. So B is gone because that's not going to be 11k. And I can see in C and D that I would have 11k. I need a negative 22. A is a negative 6. Doesn't work. 11 times negative 2 would give me a negative 22. 11 times a positive 2 would give me a positive 22. So that one is just a C. I'm going to look at, let's see, I think I'll do B on this one. So looking at the perimeter, these two would be the same size, and these are the same size. So one way to do the perimeter is x plus 3x plus x plus 3x. Another way to do the perimeter is, I know it's x plus 3x times 2. I'm going to show you another way on here, so I could actually add these all up. I could have 4x plus 4x. I could also have 8x. So there's lots of different ways that I can write the perimeter. The area is length times width for a triangle or for a rectangle. So x times 3x, and then I could actually multiply those together to get the 3x squared. And we could come up with other ways. We could actually just go ahead and say it's 2x squared plus 1x squared, because it still all means the same thing. Let's look at C. And also notice on D, it's just the perimeter. I'm not having you do areas of triangles. That's not what we're working on or focusing on. We're really just looking at equivalent expressions and writing them different ways. Perimeter. So one way is, again, that x plus 3x plus 2 plus x plus 3x plus 2. And then I could go ahead and I could just simplify all those. And I would get 4x plus 2 times another 4x plus 2, or I could put that out front. I can write this as 8x plus 4. There's so many ways. I feel like there's more ways to write perimeter just as we're simplifying. Area, the two ways that I like to write is, one is in that distributive property form. And then the next thing I like to do is multiply it out. So 3x squared plus 2x. And then I would have two different ways. We could still add to things or subtract things, or like, again, write up that 3x squared a different way, write up the 2x a different way. So there's still more ways. It just doesn't quite seem as practical. You're finishing this sheet and checking your answers to make sure that you are understanding.